given that it's going to take us maybe up to 4 weeks to really finish the entire module. So I would suggest we actually do like a summary of the roadmap that we're gonna the direction that we're heading to. Just make sure you don't really get lost. So whenever you're wondering about what we are doing at this point of the week, that in that case you can definitely refer back to the roadmap, right? Let's talk about it. So ultimately, we'll try to walk through the development process of constructing models, right? Not really just the source code, but we're constructing the models prior to implementation of a control system regulating cars on the bridge. And I'll give you some schematic views about how the system should be perceived. I'll get there in a moment. And so such controllers exemplify a reactive system. So that'll be the first application domain of the case study that we're going to talk about, right? Remember, we got 4 different domains, like a reactive system, concurrent system, sequential system, and also distributed system. So reactive system will be the first one that we're going to talk about in complete details. And so these systems typically got sensors and actuators. And in the case of the bridge controller, we definitely got sensors. But you can think about, of course, to really make the system work, you may also need actuators to really make sure you can actually control some like a hardware equipments on the around the bridge. That's something I'll leave to you. All right, so you want to always stay on top of the following roadmap, right? Let's talk about it quickly. So we are going to have a requirements documents, which we're gonna base our development of models on, for sure, right? So I'm going to talk about the requirements document in a single, actually in 2 slides on a single page on my iPad. I'm going to make sure we understand everything that we're supposed to follow, and also we will be constrained upon. And then we're going to see how each model is going to address partially the requirements, but ultimately we want to make sure the union of all the models is going to address the entire requirements documents. So that'll be the idea. Remember, we don't try to address all the properties, all the constraints in a single model. In that case, the model state space will be way too large to be feasible. So what we want to do is distribute the requirements over a series of refinements. So that'll be the idea. We're gonna before that, of course, we're gonna also review quickly about the refinement strategy to see how we should really go for each refinement. In some way, it actually makes sense about the progression for the adding details. And we're gonna start with some initial, the most abstract model. That'll be something that we're gonna cover this week, and maybe next week we'll talk about some subsequent model representing the first refinements. So that'll be the refinements of the most abstract model. You can think about this part over here like M0. And this model here will be M1, right? And also M2, which will be the second refinements, and 3 will be the ultimate refinement. And that one there should really give you a very good idea about how you should really code the system if you really want to dive into implementation. All right, so before I give you more like an overview of the refinement strategy, I would like to first of all talk about the requirements document for the bridge controller. We should really know precisely what a problem that we are trying to solve abstractly, right? Overall. Right, let's now talk about requirements. And first of all, let me try to give you a little bit more like a closer to reality analogy. Okay, we'll think about some scenario. So we need to talk about the idea between mainland and also island. We want to build a bridge between the mainland and island. And one example, since our university is based in Toronto, I'm sure many one of you have been to the exciting, beautiful Toronto Island, from downtown Toronto, taking the ferry. Let's say we or you are somehow asked to build a bridge as a replacement to ferry. Not too sure what you will want to do that, but let's say that's what you're assigned to do. And so we want to build a bridge connecting the downtown and also Toronto Island. So that's kind of the problem we want to solve, right? And the bridge itself will be subject to some constraints and also some intended functionality. That's something we would like to satisfy at the end. All right, so that will be more or less the design problem that we want to really solve. But you can think about it, definitely got some useful application in real life. Right, let's now talk about the requirements documents. And remember, we said in lab 1, requirements document can be decomposed into 2 categories of statements. One is called Edescription, the other one is called Edescription. Let's talk about one by one. And this is the formal definition of Edescription, just to revisit the definition. They have to be atomic specification, meaning that you don't really want to describe too many things into a single Edescription. Each one of them should really describe a single thing, but not more than one. That's why it's called atomic. It should be simple, it cannot be simpler. it should be of a constraint or assumption of the system's working environment. That's something that's beyond the system's control. So that's something we have to assume. Typically, they should be encoded as axiom, typically. Right, let's talk about the various environmental constraints for our bridge controller. Okay, so I summarized all the requirements into a single page, right? The color convention I typically use is, for the green ones, so these are the E descriptions. And for the red ones, so these are the R description. Let's look at the E description first, right? Let me annotate. And then, so this part here is the schematic view of the bridge controller. You can see the island, for example, Toronto downtown, and the mainland, which will be, for example, Toronto downtown, and also island will be maybe Toronto Island, the park. And we want to somehow build a bridge between them to replace the ferry. Again, not too sure why you will want to do it, but at least that's one possible job you might be assigned as a professional engineer, right? And also we got traffic lights over here, and etc. All right, let me annotate very quickly the description. So the first part over here is about the environmental constraint. So these parts over here together will actually tell you what the assumption is for the working environments. So that's the E descriptions. And typically they are used to address the working environments. The working environments. All right, let's now go over one by one. Okay, you know what? For this one, we can simply just go over on the page, and then I can also annotate on the schematic diagram if needed. All right, over here. Okay, let's make it larger over here. Okay, so you can see we got 1, we got 2, 3, 4, and 5. So we got 5 environmental constraints in total. Let's go over one by one. First one, the system is equipped with 2 traffic lights with 2 colors, green and red. Basically traffic light, right? It's not surprising, but it's definitely something we have to encode into our model at some point. 2 traffic lights. Okay, constraint number 2, the traffic lights control the entrance to the bridge at both ends of it, right? You can definitely see the schematic view over here. You can see the traffic light is over here and also over here, right? You can see the fact that it controls the entrance and exit entrance into either side or exit from either side is according to environmental constraint number 2 over here, right? You can definitely make some notes if you wish, but let me make it for you. All right. Okay, what about number 3? Cars are not supposed to pass on the red traffic lights, only a green one. Well, that was obvious, right? We are assuming that all the drivers are well behaved, right? That's number 3 over here. All right. What about number 4? The system is equipped. The number 4 here. The system is equipped with 4 sensors with 2 states on and off, right? So you can see here we got 4 sensors with 2 states on and off, right? Let's take a look over here. So we don't really see the sensors in the schematic view, but you will as we go later for the further refinements, we'll see where the 4 sensors will be situated. That's something we'll see later. Okay, but at least we got traffic lights over here. Okay. Okay, number 5. The sensors are used to detect the presence of a car entering or leaving the bridge. On means that the car is willing to enter the bridge or to leave it. So this assumption here does give us a little bit more clue about how the sensor should be situated. For example, let's see over here. If you move on to over here, let's say there is a car over here, right? Let's say there's a car. Okay, let's say there's a car over here. Let's say it is waiting to actually leave the island, right? So there should be a sensor over here. And let's say when the traffic light over here is actually turned to green. In that case, the car will be ready to leave. In that case, the sensor will be able to tell. Will be able to capture the signal, right? On the other hand, let's say if there is a car that want to go from mainland into bridge. In that case, let's say it's on its way to really to go into the island over here, and there should be another sensor conceptually over here. So when the car will actually enter into the island, in that case, this particular sensor should also capture the signal, right? So you can think about this part over here is about the entrance over here, and this sensor over here is about the exit from the island. And symmetrically, we should also get sensors that will tell us whether there's a car go into the mainland or exit the mainland, and etc. So that's why we got 4 sensors according to the environment constraint. So you can think about environment constraint number 4 and also number 5 really lay out how the sensor should be situated and what their intended functions are, right? Let me just put it down here. But we're going to see the exact working later as we introduce the proper refinements later. Okay, so that'll be environments number 4 and number 5. Number 4 and also number 5, right? That's something you want to also keep in mind over here about the 4 sensors. All right, so that's about environment constraint. We'll definitely handle them as we go for the models, right? For the corresponding model. Okay, let's now move back to the slides, and that's about the environmental constraint, the Edescription. So these are all the 5s I spoke about, I went over. And let's now move on to the art descriptions. And what's the definition for art description? Each art description also got to be atomic, meaning that you don't really want to describe more than one intended properties or functionality in a single art description. They should be atomic. They should be decomposed. Cannot be. You don't really want to make it too composite. It should be simple enough, right? So it's either for intended functionality or a desired property, right, for the working system, right? And of course, if that's desired property, you better state that as an invariance and prove it. And we got the various requirements over here. Let's now switch back to our diagram over here, right? Let's take a look. We only got 3 of them to actually go over, okay? Let's now take a look. Okay, let me just make it big enough, not too big. Okay, bear with me. Okay, good. All right, before that, let me just say that all these 3 red ones, just my convention. Just want to distinguish between the 2 kinds of description for your requirements documents. And so these ones over here are simply so-called art description. And they are for describing either the intended functionality of your system or certain properties you want the working system to really satisfy. Right? So that's actually for the purpose for the art description. All right? And of course, it should be properties. It could be more than one, of course. All right, let's now go over the art description over here quickly. Okay. Number 1, the system is controlling cars on the bridge connecting the mainland to an island, right? Basically, it says that there's a bridge over here, right? There's a bridge connecting the island and also the mainland. That's requirement number 1, right? However, it would be interesting to see for our very initial model, we don't necessarily have to introduce this bridge just yet, right? That will be the interesting bit you will see later when I talk about the initial model, right? Requirements number 2, the number of cars on the bridge and the island is limited, right? So this is really some intended property or functionality, right? The number of cars on the bridge and the island is limited, right? So we are really talking about on the bridge and on the island, right? Mainland is okay. How many cars are actually on the mainland, that's kind of beyond our control, so we don't care. So what we really care is about this part over here. Okay, I don't need to annotate it, but just this part over here, how many cars are on the bridge at any one time, and also how many cars are actually in the island. The capacity should be limited as well. So these 2 parts, the number of cars should be limited, right? That will be requirements number 2. Okay, the final requirements, the bridge is only one way or the other, not both at the same time. That's also very important, right? You can see over here. If you look at the diagram over here, so that means there should not be a car that go this way here and there's another car going this way. In that case, you might just have some maybe some clash between the cars, right? So either we have to go this way, only go from island to mainland. In which case, we have to go for a little some period of time, and then we're gonna clear the bridge, and then we want to make sure we can, before we let cars go from mainland to the island, it will be safe to do so, right? That's why it's a one-way bridge rather than 2 ways. Okay, so that's why the traffic lights over here and the 4 sensors here are so important. So that'll be the essence for what we want to capture in the model and prove. Alright, so these are the art description. Pretty straightforward, but we really want to use this example here realistic but simple. We want to use it to really illustrate many modeling and proving concepts as we go. Let's go back to the art description over here. Exactly the 3 I just spoke about, right? All right, let's now talk about some refinement strategy. And of course, this is a diagram I also annotated on my page, on my iPad. Let's talk about how we're gonna do the refinements as we go, right? So before diving into details of the models, we first want to clarify about how we're gonna do the progressive refinements, right? We're gonna see the information that we're gonna add in to each refinement. I would say for this slide here, just keep that as a reference point over here. So whenever we try to talk about details for different models, you can always refer back to this slide to see what we're doing over here. But I want to give you some overview, some big picture about how we're gonna proceed with the refinements. First of all, we're going to talk about the initial model, right? In the initial model, I just called it M0. It will address the intended functionality for requirement number 2. And you can definitely take a look at requirement number 2, but it's going to be about the limited number of cars on the island and the bridge. All right? That's the only thing we're going to address. But for other requirements, we're going to leave them to later refinements, right? So we're only focusing on one requirement in this initial abstract model. So in some way, the analysis and proof will be much simpler than otherwise if we try to prove everything into a single model, in which case the model space, the state space will be way too large to really to consider. And when we get to the first refinements, we're going to add in one new aspects that's really covered by requirements number 1 and number 3. Basically about this bridge, and also bridge is actually one way. That's what we'll try to introduce into refinement number 1, right? Of course, you can think about initial model and also first refinements. They are both models related to the same system, but we are trying to cover different aspects of the requirements in different models for the feasibility of analysis and proofs. And the second refinements, we're going to introduce even more artifacts. In this case, it will be the traffic lights, right? Remember, we talked about traffic lights, and so far we haven't seen any sensors, right? And the final refinements, we're actually going to actually introduce the sensors together with the actual system architecture, including the controller, the environments, and also the communication channels between them. Right? That's something we'll see in the final model. So all such details will only appear in the final model. Right, so you can see overall we got 4 models to actually go over, and each one of them actually simply got a manageable amount of details for us to really consider and also to analyze and to prove. Okay, let me just recap very quickly. For the very initial model over here, M0, we only focus on requirements number 2, just about the limited number of cars between the island and the bridge. Right? But in this case, we don't even need to mention about the existence of the bridge or the island or the sensors or actuator. That's something you will see, how we can observe the system from the very high bird eye view to really see how things work. Right? That's something we'll see this week. And then for the very first refinements, we'll actually try to extend the initial model by the idea about the bridge and also the bridge being one way. So that's also very important to really consider. But so far in model M0 and 1, we haven't talked about anything about traffic lights or anything about sensors, right? So that's why we have to rely on further refinements. In refinement number 2 over here, we're going to talk about any relevant requirements related to the traffic lights, which will be environments 1, 2, and 3. Edescription 1, 2, and 3. And finally, we're going to add in the remaining details regarding the sensors and also the system architecture, which will cover environments constraint number 4 and number 5. All right, so that'll be the plan for the refinements. That's something that you don't really want to lose the big picture about. That's exactly what we're going to do. But of course, for each one of them, there will be quite many details and also technical details to really fill in. That's something we'll do as we go in the coming weeks. Right, so just recall correct by construction, right, that we spoke in the very beginning of the lecture. For each model to its refinements, only a manageable amount of details will be added, making that feasible to conduct analysis and proofs, exactly what I just remarked verbally. All right, so now we'll be ready to consider the very initial model.